Hey YouTube, so tale of two ArborPresses. So this is an ArborPress I got off of eBay. One of these industrial recycling places that picks up the casts off from companies that are closed down, gone out of business, or just throwing their old junk away and replacing it with new ones. I think I paid 20 bucks for this, which is probably more than what it's worth. The shipping was 100 bucks, so overall it cost me 120 bucks to get it to California. I think it came in from Georgia or somewhere like that. And it's served me well over the last couple of years. I've used it to press bearings, out of small motors, and recently I tried to broach a keyway in a gear, and the throat on it is just too small. There's other things that are wrong with it. This is the anvil. It's something that was mocked up at the company that had it before me, but it worked just fine. Missing a handle. I mean, who cares? It's a jet. I should also add, if anybody wants it, you can have it. I just don't want to ship it. So if you live around here, come pick it up. And this is November 2nd of 2014. And if I still have it, you can have it. As long as you can drive up here, I'll throw it on your truck. At any rate, when I tried to broach this keyway, I realized the broach was too long to fit in the bore, so I had to play some games. Eventually I got it done. So there I go, look off on eBay again, as I'm wont to do, and I see these 3-ton ArborPresses for sale. The guy has got 40 or 50 of them, and he's selling them for I think it was 150 bucks each or 160 bucks each. So I got one. It wound up costing $100 for shipping. So all said and done, I think this cost me 260 bucks. Not cheap, but I needed something to do the job I needed to do, and this is all I had. I mean, I'm just in the garage. This fits. It's a little bit bigger than that one. The throat's big enough. It's made in China. My old one's a jet from Taiwan, and Taiwan is not mainland China. There's a completely different. I don't want to get into the geopolitics of it. They're two different places, and when you look at these closely, you can tell they're two different places. The new one I got, which came from the PRC, well, it's casting is kind of rough. There's not a whole lot of attention paid to whether or not things line up, and tolerances probably are a couple millimeters instead of a couple thousandths, and et cetera, et cetera, et cetera. But again, I'm not using this to make jet airplanes. I'm just trying to do some hobbies in my garage. At any rate, I expect it to work for 250 bucks. It's brand new. It should work, shouldn't it? So what I did was I had it all set up, and it's got this. Actually, it's kind of tight right now, so you wind it up like this, and then it's a ratchet, right? So we all know ratchets work. There's a pawl, there's a gear, and this pawl's supposed to fit in the gear, and it should ratchet it downward. Now, problem A, as you can see, the pawl has no spring loading to it, so it's basically, maybe that's the way these things are, but at least it should fall into the, if it's not going to be spring loaded, it should at least fall into the tooth, which it does not. All right, small problem. I can loosen this up, and maybe the weight of gravity will pull it in. But more importantly, problem B is after it's all the way down, or after it's actually got some pressure on it, when you try to yank on it, what you'll find, and for some reason it's not doing it at this very moment, but it will spring out. This pawl will come disengaged from the tooth. Now, on closer inspection, we could probably see that it's due to the shape of the business end of that pawl. It's got a bevel on it, and as you put force on it, it's going to tend to, the force is going to tend to direct it to spring outward. So, you can do any number of things here. One is, I could probably just put an edge on there and just run an edge across. The other thing I do is just put a spring on it and an edge. And I think I'll try one of those two things. Meanwhile, it's a buyer beware situation. I don't regret buying the thing. It seems to be, for what I'm going to do with it. I'm not going to be putting together any public transportation or hard valves, or for the little things that I'm going to do in my garage. This thing will work just fine. But I would like it to work. So we'll see what we can rig up here today. to get this thing to at least function. So I asked myself, what would my YouTube machinist heroes do? Well, probably they would never bought something like this in the first place, but what I'm going to try to do is I'm just going to run an end mill across the face here of this thing. You know, it's already kind of, I mean, the thing is 2 weeks old and it's already kind of gummed up, munged up from just my pulling down on it and having it spring out of its ratchet position. And you know, this stuff is soft as all get out, this material. I'm not sure what it is, but it's certainly not hardened in any way. So I'll run an end mill across it. I have a feeling at the end of the day we're probably going to wind up refabricating this thing, which is going to be a challenge for a guy like me. But let's just try this and see what happens. I don't expect much. Well, you know, there's that. So that doesn't look too bad. Let me just face it on the bottom there next. Isn't always the easiest thing for me. I have a small garage, and and things are where they are, which is not to say that they're anywhere close to where they should be. Organization is the key, and so far the wife and I, we organize 2 or 3 times a year, and then afterwards we find that things wind up where they wind up. All right, I'm going to zero that right there. Now I'll dial in 3 thousandths. So there it is. And one can only hope that it actually grabs now. It's got a flatter face on it. All right. All right, it seems like geometry-wise, it engages with this a lot deeper now. So the front end has been flattened out quite a bit here, and I took off, I don't know, 20 thousandths off that, so that's nice and flat. This presents a flat edge, so that would ride along there and then engage, and hopefully it's not inclined to do this. Now what I could do is I could put a little bit of a negative angle on that. That might help, but I think it's, you know, well, I'll give it a try. So this is interesting how they made this. So this bolt, this is actually threaded in here, although these threads have seen a better day. Not quite sure. I guess they are intending you to lock this against here so that this can remain free to move. Alright, so this is what you get now. Before I start putting pressure on it, let me tighten the set screws on this retaining ring, which itself is a joy. See, as you tighten the set screw, it pushes the retaining ring away. That's a fun, interesting feature of this. Let's try doing this one first. One of these doesn't do that. No. Yeah, they both do it. clamp that before I tighten it. Well, doesn't spring out. Doesn't spring out with that much pressure. Maybe it's fixed. Well, only time will tell. Only another usage will tell if this is actually gonna work in the actual service of a job. It doesn't spring out when I pull it down, but I haven't locked it back down to the table. So once it's locked on the table, and I get something on there, and I can really torque down on it, we can see. But it's not. I mean, it was springing out before with just that much. So hey, maybe this was a simple fix. Thanks a lot, and see you later. I'm Joe.